Yeah, so before I dig into the more into serverless, I wanted to discuss about how the IT transformation happened last 30 years. So earlier used to, we had a private data centers and or like I can say bare metal servers was there, and we used to host any application servers or database servers and any file systems deployed into that particular server. Then what happened, everybody realized that, this is very, we cannot scale it, and we have to upfront the infrastructure every time, because we never know that when we require another, infrastructure. So then, industry transformed into virtualization. Then, virtualization, with the help of virtualization, we can create different, operating systems, and we can deploy our web servers or any servers we can deploy on it easily on to the virtual system. But later, everybody was thinking that we cannot scale it, and let's say the resources we are using on virtualization, we are not utilizing 100%, and it's not scalable also, because we have to operating system is there 100%, you have to utilize it, then it is profitable. Then everybody was talking about cloud that time. Then everybody shifted to cloud. Now cloud providers has three different main platforms. One is infrastructure as a service, and second would be platform as a service, and third would be software as a service. So now again, infrastructure as a service, so end user don't have to worry about the required infrastructure. We don't have to provide any upfront in cost there. You can whatever operating systems, whatever memory, whatever CPU you can choose, and you can start working on it. You don't have to worry about the required data center part, then networking, then cooling, everything. We don't have to worry about that part would be taken care of by cloud. So mostly people started using infrastructure as a service. So then platform as a service, here we don't have to worry about the operating systems, and you can directly use vendor any provided any platform. Let's say we can give as a RDS database, right? Here we don't have to worry about the operating systems, only we have to, the service will be managed by Amazon, and we can directly work on database. That is called as platform as a service. Then again, software as a service. So Gmail is one of the best example of software as a service. You can directly subscribe, or Salesforce, you can directly subscribe and directly use for subscription, which is called as software as a service. So now last few years, let's say near about 4 to 5 years, everybody was using serverless. It was nowadays it is really buzzword, and a lot of can see benefits of serverless. So why means serverless in the sense, it's not like that there is no server, but definitely there is a server, but without we don't have to care about the scaling, traffic usage, nothing. We don't have to care anything. You have to focus on your business logic. So how it works, let me go through the slide. So any architecture, there would be three different parts. One would be let's say we are using banking application. There must be presentation layer where you can interact your, you can log in your credentials. Then let's say you have to do some transaction. Then there would be application logic would be there, and there should be database where data gets stored. That is called as multi-layer architecture. Now, when we talk about serverless, there will be definitely one physical infrastructure, and there would be any cloud provider, let's say AWS or Google Cloud or Azure. And it is divided mainly into the function as a service, which is called as more or less serverless, and backend as a service. Backend as a service as in the sense your database or any logic you have written into it. And its application means we are going to directly interact with this application. Now, function as a service is more related to the serverless concept. So I would define as architecture is it depends upon it's whereby infrastructure is total is based on cloud service provider. Okay, it's let's say maybe AWS, Azure, or cloud provider, but you don't have to worry about that infrastructure. Let's say you are any application, it's continuously dynamic. We don't know the traffic usage, and we don't know anything about the CPU utilization, how it might be. Then we don't have to worry about the required infrastructure. It automatically scales according to your traffic. So resources are dynamically allocated on demand for a given unit of business logic. Whatever you have written your business logic, it depends upon a required utilization would be provided. Let's say you want 4 MB of RAM, and let's say you want to some particular CPU usage, you can definitely allocate it into that. But here one thing we have to clear that serverless architecture means there would be a server, but we don't have to worry about it. That is, it's not like that serverless means there won't be any server. There would be server, but you don't have to worry about it. Rest, I told you that the cloud provider, takes care of the details, and only we have to focus on the code we are trying to ship. Means other infrastructure related, we don't have to worry about it. We have to focus only on the business logic. We have to try to achieve it. And and we can definitely scale your application as and when required. So there are in serverless design layers, there must be some layers are mentioned. One most important is compute layer. So this layer will be handled by cloud provider. So it will be make sure that its access and requests are properly authorized. Means nobody without your access and request will directly get access. There are some services we can use it for their authorization and authentication. Let's say API gateway. So nobody can access your URL without accessing first API gateway. So it's basically application programming interface where you can mention the required authorization and authentication. And the runtime environment, there are, let's say your code is in Java. So you can choose your code as Java. Let's say your application requires Python. The required runtime environment, you can choose it. Only thing you have to worry about your business logic. We have to write into that the code, and you have to deploy it and execute it. Okay, and these are some examples I have mentioned. In AWS particularly, it's heavily used Lambda. It's Lambda, then API gateway and step functions. These are called as serverless services, but one of the mostly widely used is AWS Lambda function. Again, AWS provides another data layer, which is called as persistent storage. Let's say your function gets triggered, but you would like to store data into some of the databases, which is called as persistent storage. I want to store that data into particular storage. So these are the 3 services Amazon provides, which is also called as serverless services: DynamoDB, then S3, and Aurora Serverless. Aurora is one of the same, it's database. DynamoDB is NoSQL database, and Aurora provides SQL provide service. So basically, you don't have to worry about the database engine. You don't have to worry about their required storage. It automatically gets scaled. These are the services automatically scaled. We don't have to worry about the scaling part. So these are the main 2 layers, which is compute layer, then data layer. So here, different scenarios we can consider when we talk about AWS Lambda. So AWS Lambda is more into the event-driven based architecture. Let's say you have an application and you have an S3 bucket. Let's say user would like to, from anywhere, from his laptop or from his mobile or cell phone, would like to upload his photo. Once he upload the photo, automatically Lambda will get triggered, and whatever you would like to do processing will do Lambda, and the data, whatever the required data of user, gets stored into the DynamoDB. It is called as eventless architecture. So here you can use RESTful microservices. So let's say here is consumer, we can access microservice. So I would like to mention microservices, the difference between monolithic and microservices. In monolithic, we build our 3 layers, which is front end, business logic, and required file servers into one architecture. We cannot scale it if you use monolithic architecture. But in microservices, the applications will be divided into the separate services. Let's say if we take the example of banking, login would be the separate service, the payment would be the another service, then add to cart would be the another service. So that every service would be scaled independently. It is not tightly coupled, or it's a single point of failure. It's a totally scalable independently. So here, let's say consumer can access application programming interface, then it will access the Lambda, whatever the microservices return the code, it will execute and it gets stored into the database. And let's say you have now streaming data. Now streaming data, those who don't know anything about the streaming data, let's say we can discuss about social media data as well, or IoT data as well, right? So we can store that data into the Kinesis, AWS Kinesis server, where we can store the real-time data into the Kinesis. Then we can trigger a Lambda once it is stored into the Kinesis, and let's say we have to do some ETL process onto the data. You would like to do some transformation, we'd like to do some messaging over the data, then you can write the code into the Lambda and it will get automatically triggered. Whatever the function you have written will do analysis and processing, and will automatically we can store that data into the DynamoDB server. So this is the example of streaming social data, how we can use AWS Lambda or serverless. These are the serverless design patterns how we can achieve using AWS Lambda. Now let's say you have a static website and you would like to store it on Amazon S3 bucket, and let's say this is static consent, and dynamically if you have any EC2 instances, or we can scale, we can store that backend as a EC2 servers, and your static would be on the front end, will be on this S3 bucket. And for authentication, you can use this service, Amazon Cognitive User Pool, which will do authentication part. And here, once you launch once you access this static web pages, we can dynamically call APIs, and the Amazon gateway will can pass, then MLM Lambda will do processing, and then it will be stored into DynamoDB again. So let's say you have web application, then this is the architecture. Let's say you have some streaming process, you can use AWS Lambda. Let's say you have RESTful microservices, you can use the Lambda service. So basically, these are I have mentioned 3 different types of server design patterns. Now, one of the most important, might be you has a question, what are the advantages? Because we can use now infrastructure as a service, we can use a platform as a service, then why should we go for a serverless or a function as a service? Why should we use that? What are the advantages? What are the disadvantages? So let me explain some of the advantages here. So basically, it's cheaper. Means function as a service allows you to pay a fraction of the amount per request. Now let's say user is accessing your application, and it will, it takes near about milliseconds to access your application, then you will be charged only for that milliseconds. Once it is the Lambda is ideal, you won't get be charged. It means application will be charged based upon the usage. Once it is ideal, we won't get charged. That's the reason it is a cheaper. And one of the another reason will be, let's say you are a startup and we don't know your application stack, how it goes, and you would like to create some MVP phase or POC phase, and it is very easy to create using serverless. and it's almost free, and we can directly launch that product into the directly market, and depends upon your usage we can decide whether we use for serverless or any other type of architecture. But initially, if you have constraints about budget and you would like to launch quickly your product into the market, then the serverless service will be ideal. And another most important part is scalable. So let's say now it's scalable. You might ask, then infrastructure as a service also scalable. Let's say you have EC2 instances and you do auto scaling part, and based upon usage we can definitely use the auto scaling launch the servers and traffic will be divided. Then why should we go for serverless then? Then here, in case of auto scaling, the volume of growth would be high, so we don't know how many auto scaling groups we require, how many scalable we have to achieve. But here in serverless, you don't have to make a choice. Means any amount of traffic can be handled by the serverless. Definitely there would be throttling would be happen because of the large volume of access, traffic access, but you can definitely achieve the performance using AWS. Given some performance and monitoring tools, definitely we can solve the throttling problems and everything. So it is more or less infrastructure as a service scalable part. It has more definitely advantages in terms of scalable or to other infrastructure as services. So you don't have to, even if you use infrastructure as a service, you have to take care of the patching, the maintenance part. Here you don't have to do anything. You don't have to appoint or hire any cloud engineer to take care of serverless part, because there is not required at all to take care of all these things. So it will definitely save your cost, and we have to only focus on our customers, our user experience and our business logic and our business, because all the abstraction whatever the required will take care by serverless, which is called as AWS. So there must be some drawbacks would be there. So one would be vendor lock-in. So let's say you have written your Lambda in Java code, okay, and let's say there is another service which is another service provided by Azure or Google Cloud Functions. They have some Azure Function Service and Google Function Service. So we cannot migrate into AWS serverless Lambda service into the Azure Lambda service. That won't be happen. That won't be possible. So there must be vendor lock-in is there. This is one of the major drawback of this service. And another would be learning curve would be there, because you have to understand how Lambda works, how to troubleshoot the Lambda. You have to learn. There should be definitely minor learning curve would be there. I would not say it's a drawback. It's a technology, then you have to learn it. But definitely there would be some learning curve would be there, because monolithic access service architecture, you have to into convert your monolithic application to microservices. So then we have to understand how we can convert your monolithic architecture into the microservices. And another example be unsuitable for long-term tasks. Let's say you have streaming data and 45 minutes of video processing. Now you have to do processing part. Then we cannot use AWS Lambda or serverless architecture for long-term tasks, because by default AWS has 15 minutes of Lambda will be run only maximum to 15 minutes. It won't be run your Lambda more than 15 minutes. So it is not suitable for any long-term tasks. Let's say in batch processing or video processing application, it is not suitable for that. So by default, it will give 5 minutes to execute one simple task, and it is more than task, then you have to obviously to call another function. But as I mentioned, let's say, sending out batch processing, like, sending out emails or processing of videos, then it won't be possible using serverless fast functions. So these are some drawbacks we have to keep in mind. So platform for serverless, these are the some platforms here I mentioned: Apache, then Fusion, Lambda, Kubeless, and OpenFast. These are the some platforms which supports the serverless architectures. So before we go to the questions and answer, I would like to demonstrate how exactly we can create the Lambda functions and how it works. I hope everybody can see, see the video. So I have logged into the AWS and I'm going to create one function. So if you see, when you create, you will get 4 different templates here. You can start your simple Lambda from author from scratch, then use a blueprint. You can use a container image, and AWS has provided the repository where you can choose directly some ready-made Lambda functions from here. So here we are creating our own Lambda function. So it would be, so I'm going to select author from scratch. So I will write my own Lambda. So the Lambda would be, we have to provide the name. It is, let's say, my first Lambda. And I have chosen the runtime environment would be, Node.js. We can, the Lambda supports a lot of, different configuration like Python, Java. Then here we can do some additional settings as well. But to run a Lambda, we have to create one role so that Lambda can work on it. I'm going to create one. I don't have any existing role. It will create automatic the required role, and we can see the Lambda is going to create it. So this is my Lambda. So by default, if you see here, this is the hello from Lambda. So for testing purpose, I have written one Lambda. So we will replace this by default Lambda code into the custom code which I have written. So this is the Node.js code which it will check Amazon Web Service whether it is reachable or not, whether it is. So this is the just simple Node.js code. It will check whether Amazon service is accessible or not. You here in this example, you can check with, you can play around with different URLs and you can check that as well. So now I'm going to test and deploy it. So all the changes have been saved now. Now we can test it. So here we have to mention this one. We have to mention the event name, and we can pass as well. Let's say your Lambda requires from different countries as an input parameter. Okay, let's say there would be India, there would be US, and based on the keys, the Lambda would get the required output. Then you can pass the values from here as well, and you have to mention the event name. So here we don't have to give any key values as such. So it gets triggered. Now we can see the result. Yeah, we can see the execution result has succeeded. Now we can see here the duration and resources configured, and it's a build duration, maximum memory used, everything we can see here. And it's in millisecond. You can see here it is required duration, it's in milliseconds, 40.39 in millisecond. Now we can, the automatically if you monitor this Lambda, we can check all the logs in CloudWatch service. We can check all the details, each and every Lambda you perform. We can see all the details in CloudWatch log service. It gets created log stream, the event name which we have given it my first Lambda, and here we can see all the details logs. If there is an error, if there is any issues, we can check into the logs as well. And there are some different tools available. We can, let's say your Lambda calls to different services, let's say S3 bucket or DynamoDB databases. We can check all the, tracing path. There is one service which is called as X-ray service, where we can see the how the Lambda is get routed into different services. We can check that as well. And another thing about troubleshooting and performance monitoring, everything is configured, and we can see all the statistics into the CloudWatch metrics, or in Lambda's console itself there. So we can trigger the Lambdas. Let's say you give threshold that my Lambda should not be take more than 2 minutes, and if it takes more than 2 minutes, then it should send me the automatic notification. That is also possible using CloudWatch alarm. We can set that, and the Lambda particularly we have to choose it, and let's say it requires to execute the Lambda more than 10 minutes or 2 minutes, you have to provide the threshold and you will get notified as well. So it's a very deep concept. So I have tried to cover as much as possible.